Hi everyone. In this session, I will be discussing one of the important chapters in physics, that is vectors. Vectors is a powerful tool in physics in describing and understanding motion of the objects in space. So, study it thoroughly and most importantly, understand it at a deep level. All the physical quantities in physics are classified into two groups. One is scalar and second one is vector. Physical quantities are two types. One is scalar and second one is vector. To describe scalars, we need only two things. One is magnitude and unit. We don't need to add any other information to describe these quantities. So these are called scalars. For example, if I say mass of a ball is 50 grams, mass of a ball is 50 grams. Here 50 is called magnitude and gram is unit of mass in CGS system. No other additional information is not required to describe this mass of a ball. So these type of quantities are called scalars. I am writing some more examples. Volume, temperature, density, work, energy. These are examples for scalars. For some quantities, we require not only magnitude and unit, but also direction. These quantities are called vectors. See, we need, for the description of vectors, we need magnitude, unit, and direction. For example, if I say a force of 50 Newton acting on a body, say this is body, one force is applied on this. So this 50 is called magnitude, this N is Newton, unit of force. So here I gave two things, one is magnitude and unit is force. So with these two informations, I can't describe this force. This is meaningless because here in which direction I am applying force, that is very, very important. In east direction or west direction or north direction or south direction or velocity, force, acceleration, momentum, etc. These are examples for vectors because they have direction and magnitude, right? All quantities which are having magnitude and direction are not vectors. One exception I am going to explain to you. Suppose current. Current is, say, I am writing 5 amperes. Unit of current is ampere. Here 5 is magnitude, A is ampere, unit. It is also having direction. Suppose if I say 5 ampere of current is passing through this wire. So it has direction and unit magnitude. But it is not called a vector. Current is called scalar. Though it is having direction magnitude, this is not considered as vector. Reason is it has to follow law of addition of vectors. Law of addition of vector. It doesn't follow law of addition of vectors. That's why the physical quantity current is not a vector. This is scalar. See here, one in this wire, say 5 ampere of current is passing. Another wire, in this 3 ampere of current is passing. These are connected to another wire. So total current is 5 ampere. 5 ampere. So 5A plus 3A. Angle between these two wires is 90 degrees. Now if I change angle to 60 degrees, 5 ampere current, 3 ampere current. So these are connected to another wire. So totally we have here 5A plus 3A, that is 8A. Here 5A plus 3A, 8A. 8 amperes of current is flowing through this wire. So here these are not following law of addition of vectors. I will be discussing this concept in next classes, right? So the current is not obeying law of addition of vectors. I will explain in the next class. So current is not a vector quantity. It is a scalar quantity. Reason is it doesn't follow law of addition of vectors. Now let us know how to represent vectors. Representation of vectors. Vectors are geometrical representation of magnitude and direction. See writing, these are straight lines. Vectors are simply straight arrows, right? Arrows. Here I am writing arrows. This arrow is used to denote vectors. So vectors are simply denoted by using these arrows, straight arrows. See here, this point is called origin or starting point or tail. Origin or starting point or tail. This end point is called terminus. Terminus or tip or head. So use these terms. This end point is called end point also. We can call it end point. End point, this point is called end point or terminus, tip, head. This starting point is called origin or starting point or tail. Simply vectors means carriers. Vectors means carriers. Carriers means they carry this point to certain direction. See, this point is moved to this point, this position. So that's why vectors are called carriers. These vectors are represented by English letters. Now I am writing, see, I am writing A. Above that, we have to place an arrow mark. This indicates this vector, vector A. Or sometimes you can choose small letters. Over that, you have to put arrow mark, right? Sometimes, if you write that letter thick, bold letters, this is also considered as magnitude. This is also considered as vector. So when this letter is written thickly, no need of putting this arrow mark. Next thing is the length of this vector is called magnitude of the vector. Magnitude of the vector. The magnitude of the vector is denoted by using modulus symbol. We have to write modulus symbol, two vertical lines. In this, we have to put this vector name. So, modulus of vector A, we have to read it as modulus of vector A. Whenever we put this modulus symbol, two vertical lines on either side of the vector, this indicates magnitude. So, magnitude of a vector is represented by this symbol. or sometimes simply you can write A. A means this is magnitude also. So in generally we use this modulus symbol to indicate modulus of the vector. Modulus of vector A we read, it indicates magnitude of the vector. Sometimes we represent vector like this also, AB. Here A is the starting point and B is the ending point. A is starting point and B is ending point. So this is called origin. This is end point. We can represent a vector in this format. Okay, I hope you understood well. If I write vector A 2 meter, this is wrong representation of vector. So whenever we write vector A or vector, here 2 meter I wrote, this is magnitude and this is unit. Here we have to mention along east direction or any direction we have to write. So magnitude, unit and direction, then only this is correct representation of vector. Vector B, it is given 40 Newton along south of 40 Newton along 30 degree south of west. South of west. So whenever you are given here south of west, east of north like that, this off after what we have, this is west. This you have to take as reference point. Reference, right? Now I am drawing, see here. This is north, south, east, west. So here reference we have to take as west. So this is west, this is reference. From this we have to move south direction. So in this we have to move south direction. How many degrees given? 30 degrees. So this indicates here 40 Newton. So 40 Newton is the 40 Newton along 30 degrees south of west. South of west. In this way we have to represent this type of picture. Here south of west. West is taken as a reference point. So from west you have to start and move in the direction of south. South direction. So south is here. So in this direction I have to move. Degrees is given 30 degrees. So up to here say 30 degrees. Then this line, this vector indicates 40 Newton along 30 degrees south of west. In this way we have to represent vectors. Now I am discussing unit vector. This is very, very important concept. Unit vector. A vector whose length is 1 unit is called unit vector. A vector whose length is 1 unit or 1 is called a unit vector. So I am writing. Say this is one vector. Say A, vector A. In the direction of this vector, I am taking a small vector. I am taking a small vector. Say this is a small vector. This length of this or magnitude of this length is 1 unit. Then this small vector is called unit vector in the direction of vector A. Suppose this is 5 Newton. 5 Newton. Say 5 Newton in east direction. Right? So this is 5 units. So I am dividing into 5 parts. 1, 2, 3, 1 up to here 1, 2, 3, 4, 5. 5 units. So I divided this 5 Newton vector into small 5 vectors. This small vector, so from here to this point, this small vector indicates unit vector. Unit vector. In the direction of this vector, I am taking a small unit whose length is 1 unit, because by dividing 5 Newton by 5, see 5 Newton east, this is given. I am dividing by 5, 5 Newton. 5 Newton, 5 Newton gets cancelled. I left with 1 east. 1 means here 1 unit in the direction of east. So this is in the direction of east. I am getting only direction from the unit vector. So this is simply written as denoted by unit vector is denoted by small letters. A cap symbol is put over the A. So unit vector A is equal to vector A by modulus of vector A. So here we have to write vector, then divide by magnitude of the vector. This will give us unit vector. Observe this one, 5 Newton east. I am dividing this 5 Newton east. This is direction, this is magnitude. I am dividing by this vector. Here magnitude and direction it is having. So it is a vector. I am dividing by this by only magnitude 5 Newton. So 5 Newton magnitude is cancelled. We left with direction and 1 unit. 5 by 5 means 1 unit. So this 1 unit vector is called unit vector. So unit vector is simply written as A cap, that is vector A by modulus of vector A. Modulus of vector A. You can use capital letters also. Unit vector A cap is given by vector A by modulus of vector A. So to find unit vector, you have to write vector and then divide by its magnitude to get unit vector. From this we can write, send this modulus of vector A this side. A cap into modulus of vector A will give us vector A. So A cap into modulus of vector A is equal to vector A. Unit vector along x, y, z axis are I cap, j cap and k cap respectively. This you have to remember. Now I will explain that. This is y-axis, this is x-axis. Now z-axis, it will be perpendicular to me like this. This is perpendicular. I can't draw on screen. So that's why this is indicated like this. This is say z-axis. These x-axis and y-axis and z-axis are mutually perpendicular to one another. These are perpendicular. I will show you like this. These are perpendicular. I don't have anything here. Like this, these are perpendicular. In this way, x-axis, y-axis and z-axis. Remember this. This is y-axis, this is x-axis and this is z-axis. So one unit vector in the direction of x-axis is represented by I cap. Unit vector in the direction of y-axis is indicated by the letter j cap. In the same manner, unit vector along the z-axis is represented by k cap. These x-axis, y-axis and z-axis are mutually perpendicular to one another. Mutually perpendicular to one another. Magnitude of I and magnitude of j, magnitude of k, these all are equal to 1 because their magnitude is 1. Now let us discuss another important thing, that is resolution of a vector. Resolution of a vector or components of a vector. Components of a vector. Vectors at an angle. Here, this is a vector, say A, vector A. This is x-axis, this is y-axis. The projection of vector A on x-axis, the projection of vector A on x-axis is called AX or component of x-axis. Component of vector A on x-axis is AX. Component of or projection of vector A. It is denoted by Ax, and component of vector A or projection of vector A on y-axis is represented as Ay. Now we are taking this Ax, right? I am writing Ax by A. Ax by A. Here Ax by A. Ax is, so here right angle triangle is formed. This Ax is called, say this is hypotenuse. Slant line is called hypotenuse. So here theta, this is opposite side, this is adjacent side. So now Ax is considered as adjacent side by this vector A. This A is hypotenuse. So adjacent side by hypotenuse, that is cos theta. From this, Ax is equal to A into cos theta, A cos theta. So horizontal component of this vector A is A cos theta. Horizontal component of A is represented by Ax, that is equal to A cos theta. In similar manner, if I take Ay, this is Ay, this is equal to this line, this perpendicular line, this is Ay, because length of this one and length of this one same. So I am taking Ay, this will be opposite side, this Ay will be opposite side. So I am taking Ay by A. Ay is opposite side and A is hypotenuse. Opposite side by hypotenuse, this is definition of sin theta. So from this, Ay is equal to A into sin theta, A sin theta. Ay is equal to A sin theta. This is y component of vector A. Carefully listen to me. Y component of vector A is Ay, that is A sin theta. From this, we know that any vector, say vector A represented as Ax I cap plus Ay j cap in 2 dimensions. If you want to represent a vector in 3 dimensions, you can write like this. Vector A is Ax I cap, this is in x component, and Ay j cap and Az k cap. So remember this, how to represent a vector mathematically. So an example, vector A is 2 meter along east direction. So for this, we have to draw this coordinate axis, x-axis, y-axis, 2 meter in the east direction. This is east direction, 2 meter. So first we have to write 2 meter, 2 in the east direction. So I cap we have to write, I cap, 2 I cap. So for this vector A, 2 meter along east, this is replaced by simply 2 and I cap, means 2 units in the direction of east. Another vector, say vector A, 4 meter along 30 degrees north of east. So for this, I am drawing this x-axis, y-axis. This is east, this is west, and this is north and south. So here, whenever you are given north of east, after we have east, this is reference point. From this you have to start. So from east you have to move towards north. So from this east you have to move towards north. North is this direction. So here we have to make an angle 30 degrees. So this vector indicates 4 meter. We have to write this 4 meter along 30 degrees north of east. So this is vector A, 4 meter, and it is making 30 degrees east of north. That means you have to start from east. East is taken as reference. Now, how to represent this diagram mathematically? So, just now I told you one thing. So, this vector must be divided into two components. So, here 4 meter, 30 degree is given. This horizontal component will be 4 cos 30. Horizontal component cos theta, vertical component sin theta. AX is cos theta, AY is sin theta. So A is here 4 cos theta. This Y component will be 4 sin theta. 4 sin theta. Sin theta means theta 30 degrees. So horizontal component AX is 4 cos 30. This value we have to calculate. 4 cos 30 degrees is root 3 by 2. 2 to the 4. This will give us 2 root 3. And Y component AY is 4 sin 30. 4 sin 30. So 4 sin 30 one out half 2 ones 2 to the 4 2 1 2. Now vector A I am representing as AX I cap plus AY j cap. In the place of AX I cap I am writing 2 root 3 units and put I cap plus 2 units. This is j cap. So vector A can be represented mathematically as 2 root 3 I cap plus 2 j cap.